In today's video, we are going to learn how to create a multiplayer game in Unity using Photon. We are going to use the chess project from the previous video and add a multiplayer functionality to it. Let's take a look at the plan. First, we will learn how to set up a project in a Photon dashboard. Then, we are going to modify the board class. We will make the board class an abstract class and create two separate classes, a multiplayer board and a single player board class that will implement the abstract board class differently. We still want to have our single player mode playable. Other objects that work in the same way with both game modes should just work with the abstract board class. Next, we will learn how to use Photon API to connect to a server, create a room with different properties, join already created rooms and set player properties. Next, we will modify the chess game controller class similarly to the board class modification. Then, we will take a look at the different ways that Photon synchronizes game state. We'll briefly talk about all of the possible ways and implement remote procedural calls to synchronize the board data and piece movement. And lastly, we will create a game initializer script that is going to create a game based on selected play mode. But before we start, a little introduction. You are watching GameDevChef, a game development channel with wide-ranging quality content. You can learn here how to implement popular game features, create your own AI systems that you will be able to use in your own games. You will learn here how to develop for various platforms like PC, mobile, VR, and even create fully functioning games. Please consider subscribing and help us grow the channel stronger. First, we need to download the Photon PUN 2 package from the asset store. We will use the free version that can handle up to 20 concurrent users, which is more than enough for our test purposes. After importing, a pop-up asking for the game identifier will show up automatically. Identifier is created in the Photon dashboard. So let's log in there and click the Create New App button. Here we have to select Photon PUN as the Photon type and set the game name. We can leave the rest for now. Now click the Create button. Now we should be able to see our game in the dashboard, so let's find it and copy the identifier. Back in Unity, paste the identifier into the PUN setup window and click the Setup Project button. Now let's find the Photon server settings asset. This asset holds all the data that Photon will use to connect to its servers. As we can see, there is our game identifier provided already. Let's also add a game version. This is a way that we can separate players with different game versions when the backwards compatibility is broken. Now let's create all of the UI objects and have that out of the way. They are gonna be very simple and similar to the game over screen, so let's just copy it for every new window. First window will be a game selection screen where we will choose what game mode we want to play. Next, we will need a screen to select a team when in the multiplayer game mode, and a screen where we will choose our skill level and start connection to the Photon servers. Now let's add the proper UI elements to each screen. Let's start with the game mode selection screen. Here we need two buttons for selecting a multiplayer or a single player game mode. I will speed up the video here. Creating UI is not the essence of this video and is not even that interesting right now. So if you are following along, please stop the video and take some time to create UI elements. Next, the connect to the game screen, one button and one dropdown. Remember to remove the default dropdown options. We will fill them from a script. And the last one, the team selection screen. Same as with the game mode selection screen, two buttons for the white and the black team. At the end, let's put them in order of appearance in the game. Now we are ready to start writing code. As we said at the beginning, the parts that have to be synchronized are board data and game state. So we will need two different board implementations. Most of the functionality will be shared, so we will make the board class an abstract class that will require inheriting classes to implement certain methods. Two things that should be synchronized are actions taken when a piece is moved and setting the selected piece reference, so that all clients could move the piece. So let's add two abstract methods that will handle that. Also, to simplify our work, let's replace the vector2int type to vector2 type in the parameter. Photon already knows how to pass vector2 type through the network, and we won't have to write any new code to handle passing the vector2int type through the network. In the onSquareSelected method, let's call our new abstract method in the place where a piece is moved. Next, let's change the parameter type to vector2int in the selectPiece method. Because now we are passing just coordinates, let's find a piece occupying those coordinates. Then, instead of simply setting the selected piece reference, we will call the abstract method that each board type will implement differently. The single-player board will do exactly what was here before, but the multiplayer board has to do it over the network. Lastly, let's quickly fix passed arguments. Now, back in Unity, let's create a new script called SinglePlayerBoard and open it up. This class has to inherit the abstractBoard and implement its abstract methods. In the selectedPieceMoved method, first we have to convert the vector2 argument to vector2int and simply call the onSelectedPieceMoved in the board class. But first we have to make it accessible. Let's also remove the piece parameter. We already have that reference in the selected piece variable. Now, back in the single-player board script, we can call the onSelectedPieceMoved method. In the setSelectedPiece method, we will do pretty much the same. First convert vector2 to vector2int, and this time call the onSetSelectedPiece method that we have to create in the board class. This method will simply assign the selected piece variable to a piece occupying coordinates passed in the parameter. And I think we didn't break anything and the single player functionality is not broken. Last thing, I had a problem with attaching components to the board game object, so let's just remove the require component attribute from the board input handler class definition. So let's go back to Unity and test it. First, we have to replace the board component with the single player board component and fill its inspector values. Then find the chess game controller and assign the board inspector reference and hit play. And as we can see, we can still play the single player mode like we did before. Looks the same to me. Now that we have that out of the way, we can start working on the fun part, multiplayer. Let's create an empty game object called Network Manager and attach the Network Manager script to it and open it up. First, we have to import the Photon.PUN namespace. Our Network Manager has to react to messages sent by the Photon servers. To enable it, we can inherit our class from the MonoBehaviorPun callbacks class. We will take a look at those messages in a second. But first, let's see how a connection to Photon servers is created. So let's add a new method called connect. Connecting to the Photon servers is performed by a single line of code. Photon network.connect using settings. The settings that this method is referring to is the asset that we were looking at earlier. It contains all the data needed for Photon to connect. Now let's take a look at those callbacks that were mentioned before. I'll make a separate region for them. When we type override, we will see all methods that are going to be called by Photon whenever some event happens, like player connected to a server, player entered a room, etc. Let's override the first method called connected to master. It will be called whenever a client connects to the Photon servers. When we take a look at the base class implementation, we will see that it is empty. In fact, every method that we can override is empty, so we can safely remove the base class method call. For now, let's just log something. We will use log error, not because it is an error, but we will be able to see all error logs in the build console as well. The next logical step after connecting to the server is to look for a room to play in. The simplest way is to call the Photon network.joinRandomRoom method without any parameters. Later in the video, we will see how to create different kinds of rooms. Next, Photon will trigger one of two callbacks: onJoinRoomRandom failed or onJoinRoom. We should take care of both, but let's override the onJoinRandom failed first. First, let's log why we're not able to join the room and inform that a new room is going to be created. The simplest way to create a room is to call the PhotonNetwork.createRoom method. This method requires us to pass a room name, but nothing is stopping us to just pass null here. Now we can override the onJoinRoom method. We can find ourselves there by finding an existing room when calling PhotonNetwork.joinRandomRoom method, or after creating a new room. After a client creates a room, he has to join in. Photon does not allow clients to just create a room and not join in. Let's log that player has joined a room. We can identify a player by his actor number. We can find it in the PhotonNetwork.localPlayer.actorNumber variable. The actor number goes from 1 and increments by 1 every time a player enters a room. So if the second player would join a room, his actor number would be 2. The onJoinRoom method will be called only on the local player that has joined a room. That means that if a remote player would enter the room, we, the local player, would not get that callback. Callback that is triggered on a local player when a remote player enter is called onPlayerEnterRoom. In the parameter, Photon will pass a reference to the remote player. We can use that reference to log the actor number of that player. In the connect method, we should check if we are already connected, and if so, we should start looking for a room. So let's add an if statement that will take care of that. Now that we have created our first network manager iteration, we should get back to our UI and test it. So open the chess UI manager script. I will go through this pretty quickly. It's going to be pretty easy. We have to basically write it all over again. First, let's add a header for scene dependencies. We need to have a network manager here. We actually don't need it, but it came to me after recording the video, so we will have to live with that. Next, the button references. We need references to the team selection buttons. We are going to disable a button if the first player in the room have already chosen a team. Next, a header for the text objects, the result text and the connection status text. When choosing the multiplayer mode, we will display the state of the client connection. Next, let's add a header for the references to the screen game objects that we have created at the beginning. So for the game over screen, the connect screen, the team selection screen, and the game mode selection screen. And the last reference to the dropdown, where later we will choose the skill level of the player pool. Now let's remove all of the existing code and start over. We don't have a proper UI state machine here, so the code will be very rudimental and not good quality, but it will get the job done for this video. Let's start with the awake method. Here we have to disable all screens but the game mode selection screen. Next, add a method that will be called when the single player mode is selected. In that case, we just start the game, so we can disable every window. Let's also add a separate method that will disable all windows. That way, we won't need to duplicate code every time we want to enable some window. Now, add a method that will be called when the multiplayer mode is selected. First, let's enable the connection status text that will help us to debug the state of our connection to the Photon servers. After that, we should enable the connect screen. Now a method called when the connect button is clicked. Here we want to just call the connect method in the network manager. Like I said before, the network manager reference is not necessary here. We could just hook up the network manager connect method to the button event. Back in the chess game controller, we have to remove two old method calls that now are giving us compilation errors. Now find the multiplayer mode button in the hierarchy and hook up the onMultiplayer mode selected method from the chess UI manager. Same with the single player mode button, but choose the onSinglePlayer mode selected method. let's fill all of the inspector references in the Chess UI Manager component. We also need a new text game objects for the connection status text, so let's just add one. Now we can finish setting up the Chess UI Manager component inspector fields. One last thing that we have to do is to update the connection status text. So in the Network Manager, add an update method that will set the connection status text. The connection status is stored in the Photon network client state variable. Let's quickly add a method in the Chess UI Manager that will set up the connection status text to the passed parameter value. Move it to the bottom of the script and make it public. Now back in Unity, fill the Network Manager inspector, then find the connect button and hook up the onConnect method from the Chess UI Manager. Now enter play mode, then click multiplayer button, then click the connect button. As we can see, the status of our connection changes, and when we have successfully joined a room, the connection status says joined. Let's look at the console. As expected, first we connected to the server, then we tried to join a room but failed, and then we created a room and joined successfully. Now let's build the game in windowed mode and check if we can connect to the same room from two different application instances. First, let's connect in the build instance. We should see the same logs as before. Now connect with the Unity editor, and in the build we should see a log that player 2 has entered the room. And that's exactly what happened. In the Unity console, we should not see a log telling us we didn't find a room because a room was created by the player in the build instance. And there is no log like that, so everything works as intended. Now let's see how we can fill the room by properties. In our case, the only property will be a skill level called chess level. Chess level is going to be an enum with 3 values: beginner, normal, and pro. I forgot to add one thing. In the awake method of the network manager, we should set the Photon network.automatically sync scene variable to true. That way, all players, even those that join later, will join to the actual state of the scene. Now back to our room. To find rooms with expected properties, we have to pass them in the parameter of the joinRandomRoom method. Those properties are passed using the Photon hash table structure, which is an extension of dictionary. Now let's add a constant string for the key of our key value pair, then add a pair with the just created key and a player level variable as a value to the hash table. When passing room properties, Photon also requires us to pass a maximum number of players that can enter the room. In our case, it's simple. Only 2 players can play a game of chess. So let's add another constant for maximum numbers of players and pass it as the second parameter. Let's copy this line of code and paste it in the onConnectedToMaster method. A log telling us that we are trying to find a room with a certain chess level would be very helpful, so let's add one. And also paste it in the onConnectedToMaster method where we are doing the same. In the onJoinedRandomRoomFailed method, let's also add information about the room properties. To create a room with given properties, we need to pass a parameter in the createRoom method. This parameter is an object of type roomOptions. Here we can specify properties for a new room. First, we need to define all properties that are used by the lobby. Lobby is a collection of available rooms. So, as the custom room properties for lobby variable, we will set a new string array containing all possible room properties. In our case, it's just the one property for a player chess level. Next, the maximum players variable, and then the custom room properties that is of the same type as we passed in the joinRandomRoom method. So, a hash table with only one entry, level as the key, and the player level as the value. Let's also extend our log in the onJoinedRoom method. Because we are already in the room, we can access the room properties from the room itself. Properties are stored in the Photon network.currentRoom.customProperties variable. Now we will need a method that will set the player level variable. So let's add such a method. Here, first we will set our local player level variable, and then we have to inform Photon that the player properties were changed. We do it by calling the setCustomProperty method on the local player object. Just like with room properties, we pass player properties as a hash table. This method will be called when clicking on the connect button. So in the Chess UI Manager script, in the connect method, call the setPlayerLevel method from the network manager. As the level, we will pass the selected value from the drop-down menu. If you remember, we removed all options from the drop-down component because we want to fill them dynamically. To do so, we have to call the addOptions method in the drop-down class, and as a parameter, we will pass a list of all options. In our case, it will be a list of all chess level enum values. Now let's go back to Unity and test our new room creation. So enter the multiplayer mode and select different levels. You should see them logged in the console. Now let's build and try to enter with a second player. First, let's try to enter the same level on both instances. Here we should see the same behavior as before. Now, let's try to enter a room with a different levels. As expected, both clients didn't find an existing room and created their own rooms. Now, let's create the game in Unity and select the same level as was selected in the build. Now, the second player should appear in the room created by the build player. Next, we can take care of selecting a team color. After a player has joined a room, we should prompt him to select a team. So in the onJoinedRoom method, let's call a method on a Chess UI Manager that will enable a team selection screen. Let's create this method in the Chess UI Manager class. Here we just have to disable all of the screens and then enable the team selection screen. Now let's add a method that will be called when the team button is clicked. As a parameter, we will use an integer instead of an enum to be able to set it up in the inspector. Next, the method in the network manager that will set the player team property. It's basically the same as with the player level property, but as a key we use a different string, and as a value we will use the method's parameter. Now let's add a method that will disable a button for the team that is occupied by a different player. First, we have to check if there is more than one player in the room. If there would be only one, that would mean that we are alone in the room. If that condition is met, we store the first player that entered the room in a separate variable. We can identify the first player by his actor number being 1. Then we want to check if the player has already selected a team. If he did, his properties hash table should contain the key team. If that's true, we retrieve that value as an occupied team and pass that information to the Chess UI Manager to disable a button. Chess UI Manager will disable the white team button when the passed team color in the parameter is white, or black team button when the team color in the parameter is black. Back in Unity, hook up proper methods to team selection button events. The black button should pass 0 in the parameter because it's the first value in the enum. The white button method parameter should be 1. Now let's build the game and test the team selection. On the one player, choose a team and then connect with the second player. Doesn't matter which one you choose to connect first. As you can see, after selecting the white team by the first player, the second player has the white team selection button deactivated. We are going to instantiate a board based on selected mode, so let's find the board game object in the scene, change its name to single player board and make it a prefab. Now, to create a multiplayer board, break the prefab instance on the single player board, change its name to multiplayer board and remove the single player board component from it. Let's create a new script called multiplayer board and add it as a component to the multiplayer board game object in the scene. The board game object is going to be a network object. That means that this object will be shared between the players. is going to be instantiated only by the first player that enters a room. Photon identifies objects as network objects by their Photon view component. There are three methods of synchronization in the Photon network. Object synchronization: in a nutshell, Photon will synchronize values in a given component constantly. Very useful for data that constantly changes and has to be updated per frame basis, like player movement and its transfer component and its animator component. Second one, RPC, which stands for Remote Procedural Call, is a method that is called on one of the clients, and Photon will perform the method on every other client. Very useful for things that happen less frequently, mainly player actions like shooting. And the third option, setting custom properties. We have seen it already, best used for rare updates like changing player state. Probably best option for our multiplayer board is going to be an RPC, so let's take a look how it works. So back in the multiplayer board script, let's inherit the board class and implement the abstract methods. The RPC calls are performed not by a class that holds the RPC method definition, but by the Photon view class. So let's cache the Photon view component in the awake method. We have to override the awake for the board implementation, so let's go back to the board class and make it virtual. And now let's override the awake method with the getComponent call. Let's also add the requireComponent attribute to the class declaration. Like we discussed earlier, we want to synchronize method calls by using RPCs. Calling an RPC method is performed by calling the RPC method in Photon view class. The first parameter is the name of the method. Let's create some name for our RPC, for example RPC underscore onSelectedPieceMoved. Then we have to define which clients should perform this method. In our case, we are calling it on every other client, so all buffered. The last parameter is an array of objects that represent parameters for our RPC underscore onSelectedPieceMoved method. Let's generate our RPC method. Photon will only recognize a method as an RPC when a proper attribute is added to it. This attribute is PUN_RPC. The body of our RPC method is going to be the same as the body of the selectedPieceMoved method in the single player class. So let's just copy paste both of those methods. Let's also add an RPC call in the setSelectedPiece method. With the board ready for multiplayer, there is one more thing that has to be synchronized: the game state. The game state is held by the chess game controller. So just like we did with the board class, we'll create two separate game controllers that will inherit an abstract chess game controller class. So back in the chess game controller, go to the class definition and make it an abstract class. We need some abstract methods for our single player and multiplayer boards to implement. Let's add a first abstract method called setGameState. Because we already have this method in the chess game controller class, we need to remove this old method. And let's make the game state enum public. Back in Unity, create a new script called Single-Player Chess Game Controller and open it up. Here we will do the same as before, so just setting the state variable in the chess game controller to the value passed in the method parameter. So nothing really changes and our single-player mode should work as before. Back in Unity, let's prepare the single-player board prefab. First, select the Game Master game object and switch the chess game controller component. Assign the board layout reference, leave the board and UI manager references empty. Those are references to scene objects, so we'll have to pass those references after board instantiation from another script. Lastly, change the object's name and save it as a prefab. There are two more differences between the single player and the multiplayer chess game controllers. Let's define them by two more abstract methods. First, that will be responsible for starting a game. A single player board will do automatically, and the multiplayer board will start the game only when the room is full. The last abstract method will be a method that will check if a player can perform a move. The multiplayer board will additionally have to check if the active player is the same player as the local player. In the start new game method, let's switch the last line, where we are just setting the game state, to the try to start game method. Now I see that those method names are not descriptive and should be changed to something different, but let's not worry about that right now. In the onSquareSelected method in the board class, let's add a check if the player can perform a move. Okay, so back in the single player game controller class, let's implement the newly created abstract methods. We don't want to change any functionality that we had before. In the canPerformMove method, we will, like before, only check if the game is in progress, and in the try to start game method we will set the game state to play. Back in Unity, let's prepare a multiplayer board prefab. First find the single player game master game object in the scene, break prefab reference, and change the name. Now create a new C# script called multiplayer chess game controller and open it up. First, inherit the chess game controller class. The multiplayer controller is going to use another way of performing callbacks on other clients. We can do it also by events. Events, opposite to RPCs, don't have to be called from network objects with Photon View component on them. Local objects can do it as well. To make a class listen to events, we have to implement an interface called IOnEventCallback. And it has to register itself to the Photon as a target callback. Also remember to remove it as a target callback when the object is disabled. Before continuing with the events, let's quickly implement the rest of the abstract methods. The canPerformMove has to check if the game is in progress and additionally check if it's the local player's turn. Let's add a method called isLocalPlayer'sTurn. In it, let's just compare if the local player is the same as the active player. And of course we have to make the active player protected, so we will be able to access it from inheriting classes. Right now, we don't have any local player variable, so let's declare one in the multiplayer chess game controller. We also need a method that will set the local player reference. This method will be called by the network manager when a player selects a team. Like with the active player variable, we have to make the white player and the black player variables protected. Let's call this method from the network manager in the place where we are selecting a team color. Right now we don't have a reference to the multiplayer chess game controller, so let's add a field for it. Also add a method that will pass that dependency in a parameter. Shortly, we'll create a script that will set all of those dependencies, so don't worry. Now we can call the setLocalPlayer method. For the try to start game method, we need a reference to the network manager so that we can ask if the room is full. So the multiplayer chess game controller will also need a method to set that dependency. So let's add a check in the try to start game method that will see if the room is full, and if so, the game can be started. We don't have yet a way to check if a room is full, so let's add such a method to the network manager class. The method will simply compare the current room's player count to the current room max player count. Back to the event. To raise an event, the raising method needs to pass a parameter of type raisEventOptions. Here we can specify different configurations for raising events. We will just set the receiver's variable to all clients. Next, we can call the raisEvent method from the Photon network class. The first parameter is the event code. It's an identifier for the event, and by this identifier, receiving clients can identify an event. Let's add a constant variable for a setStateEvent code. Now we can use that code as a first parameter in the raisEvent method. The second parameter is going to be an array of objects that is going to represent event data. The next parameter is going to be the raisEventOptions that we created earlier. First, we have to identify the event by its code. If the event code in the event data passed in the parameter is the same as the setStateEvent code, we should try to receive the custom data. Custom data from received event is the same data structure as the second parameter in the raisEvent method. So we should have an array with one element that can be casted to the game state. At the end, we can set the game state to the game state that we receive from the event data. Back in Unity, select the multiplayer board game object, set its inspector values and save as prefab. Next, find the multiplayer chess game master game object and add multiplayer chess game controller component to it, set the board layout reference and save it as a prefab. Now we have every prefab ready to be instantiated, and we can remove the board and the controller from the scene. Now let's create an object that will be responsible for initializing a game based on selected game mode, and for setting dependencies to instantiated objects. So create an empty game object called GameInitializer first. Then create a new C# script called GameInitializer and open it up. This script will be responsible to instantiate proper prefabs based on selected game mode and fulfilling all of their necessary dependencies. So first, let's add a header for game mode dependent prefabs, so controllers and boards. If you remember, we didn't fill the inspector references for board and UI manager in the board components. The game initializer will set those references, so we need to set them up in the inspector of the game initializer first. So add serialized fields for all of the necessary scene dependencies, so network manager and chess UI manager. Let's also add a reference to the board spawn parent that is already in the scene. Next, we need a method to instantiate the proper board prefab. Let's start with the multiplayer board. Here we will see how instantiating a network object is performed by Photon. Instantiated network objects have to be instantiated only by one of the players in the room. Other players don't need to do it because Photon will share this object between all clients. So let's instantiate a board only when a room is not full. In the result, we want only the first player to instantiate our multiplayer board. The method that is responsible for instantiating network object is PhotonNetwork.instantiate. This method as parameter takes a prefab's name, it's opposite to the Unity instantiate where we pass game object reference, but the rest is the same, a position and a rotation. Because we are passing a prefab's name in the parameter, Photon needs to load that reference from somewhere. By default, it is the resources folder. We could implement our own pooling system that would fetch prefabs in a better way, but let's leave that for now. So to make instantiating work, we need to move the multiplayer board prefab to the resources folder. Back in the game initializer script, let's take care of instantiating a single player board. Here we will just use a simple instantiate method with a board anchor to transform as a parent. Next, let's add a method responsible for instantiating a chess game controller and initializing all necessary dependencies. First, let's find a multiplayer board in the scene. I'm not proud that I'm using findObjectOfType here, but it will get the job done. If we find the board, we can continue. Now we need to instantiate a multiplayer board. Because it's not a networked object, opposite to the board, we instantiate it locally. If you remember, the chess game controller uses events that can be called from a non-networked objects. We have a problem. We named a method that sets network manager reference the same as a method that sets references in the base controller class. Because network manager is only a reference in the multiplayer controller, let's change the method name to setNetworkDependencies. Now let's fix the setDependencies method in the base controller class. The board and the UI manager reference have to be passed in this method, so let's remove the serializable field attribute from those fields. Let's move caching the pieceCreator component to the awake method. Also, make the createPlayers method public. It's a part of initializing a game, and it will be called by the GameInitializer object. Now add the chess UI manager and the board as parameters to the setDependencies method and assign to the proper class members. Back in the game initializer, call this method with proper references passed. Then let's create our player objects and set the network manager reference. Then we need to set up references in the other objects. So call the setDependencies method in the network manager and the board objects. Now in the board script, in the start new game method, we can remove the call to the setDependencies method. Let's add a new method to the GameInitializer class called initializeSinglePlayerController. Here we are going to do almost the same thing, but first we will look for the single player board, then instantiate the single player controller, set base class dependencies, create players, and set the board dependencies. We would stop here in the multiplayer method, but here we can just start the game and call the start method from the controller object. Let's go back to Unity, add the GameInitializer component to the GameInitializer game object, and fill all the inspector values. Next, let's hook up all of the UI buttons to proper methods. The single player mode button needs to first call the createBoard method from the GameInitializer, then call the onSinglePlayerMode selected method from the UI manager to disable all UI, and lastly call the initializeSinglePlayerController method from the GameInitializer. Now let's hit play and take a look if we are initializing the single player game correctly. At the first glance, it looks like everything works as before. It passed the programmer's test. Next, the multiplayer mode button. Here we just want to switch UI to the connect screen. So just calling the onMultiplayerMode selected method from the UI manager is what we need. Next, the connect button. Here we are not going to change anything, we just want to call the connect method here. And lastly, let's check the team selection button. And they are set up correctly already as well. We still lack calling the createMultiplayerBoard and the initializeMultiplayerController methods from the GameInitializer. So let's think, where do we want to call them? I think the best place to initialize the controller is when a player selects a team color. So we will do it by having a reference to the game initializer in the network manager script. But when I think of it right now, we should not make the network manager dependent on the game initializer. I think having network manager raise events and game initializer subscribing to those events would work better. But it's a bit too late, the video is already recorded, so let's continue and call the initialize multiplayer controller from the select team method. And below we call the start new game method. Let's quickly go to the start new game method and see if we need to change something. Okay, so we need to hide the UI, so let's add a method for that. In the method we have to disable all screens and the client status text game object as well. Now let's think where we want to instantiate the multiplayer board. I think we can do it whenever a player joins a room, just before selecting the team. So let's call it from the onJoinedRoom method in the network manager, and again, events would work better here. Now a few fixes for bugs I've introduced to the code. First we need a PUN RPC attribute to the RPC underscore onSetSelectedPiece method. Next let's add a null check to the chess controller in the onSquareSelected method in the board class. And lastly add a not sign to the isGameInProgress check in the multiplayer chess game controller class. Now the last script, and we will be ready with everything. This is going to be a simple script that changes a camera position based on the selected team. Let's call this script camera setup. First add a serializable field for the camera reference. Then add a method called setupCamera with team color as a parameter. The camera in the scene right now is set up properly for the player on the side of the white team, so we'll flip the camera just if the selected team is the black team. To place the camera correctly on the other side of the board, we need to move the camera to the opposite side of the board. The opposite side has the negative Z value in its position, and we also need to rotate the camera 180 degrees in the world's y-axis. Now let's add a method called setupCamera to the chess game controller class that will simply call the same method in the camera setup object. We do it because we don't want to have dependencies to the camera setup anywhere else but the controller. We don't have yet the reference to the camera setup, so let's add it in the setDependencies method and add a class field. So we want to place the camera based on the selected team. We should call it from the select team method in the network manager. Now we need to add a camera setup inspector field in the game initializer and add it to the setDependencies parameters. Lastly, let's add a method in the UI manager that will be called when the game is ended. Here we have to enable the game over screen and set the result text with the information which player won the game. Okay, so let's test the finished game. Go to Unity and hit play. And there we go. Everything works. We are synchronizing the piece movement, board data, and the game state. And as always, you can find the whole project on GitHub in the description below. I hope you enjoyed it, and please leave a like and subscribe if you like my content. Also leave a comment, I'm happy to answer all of your questions. Take care.